Hi everyone, I'm Anashwara. I'm a one member team. The theme of this project is to develop and utilize an emulation based system for distributed file storage and also parallel computation. To achieve this objective, I decided to use Netflix datasets. With this, I'd like to introduce the title of my project, that is Netflix analysis using MapReduce. Just to give a little background and motivation behind this project. Netflix is one of the most popular over-the-top pop platforms, which streams many TV shows and movies. They have over 200 million subscribers globally, and with the rise in their popularity, these numbers are going to continue to increase. The motivation behind choosing Netflix datasets was when I learned about Netflix's predictive analytics. So I was quite intrigued by how they utilize data to cater to their business requirements. For example, they would use information such as country popularity or genre and even type popularity, just like this, to kind of gain insights as to what the usage of the users are. And also this can be helpful for improving any kind of recommendation system for the users and targeted the region wise content for the users. So it's pretty interesting as to how you can glean meaningful insights from this information and improve your business needs and business requirements. So, to create this project, I used data sets from sources such as Kaggle and also data.world. So, the main reason for using these data sets were that there was a wide variety of attributes for these data sets, such as you can see the title, director of the movie or the series, and the cast. And same equally, even in data.world, there's a wide set of attributes that you can use to play with your data sets, and these attributes are extremely useful for gaining insights into subscribers content consumption. Moving on to the design and implementation. To achieve the objective of the project, I had to design and implement three subtasks. The first task was to employ Netflix dataset to build an emulated distributed file system. The second task was to emulate partition based map and reduce on these datasets which were stored in the EDFS. The third task was to develop an app that utilized the implemented partition based map and reduce search functionalities. So now let's move on to the first subtask. The first subtask is to build an emulated distributed file system. As a part of the first subtask, I have implemented functions to parse and process command line arguments to execute their corresponding functions such as help, make dir, ls, just to name a few. Now let's switch to the terminal to take a look at the command line options. The user can enter edfs.py -h. Upon entering it, the user can see the entire help message. Let's move on to the GUI. To enter the GUI, the user has to enter edfs.py-GUI. Once entered, the user can see an EDFS viewer, which is an interface which has incorporated all the EDFS subcommands. The first is you can see that there's a create a directory option, there's list a file option, show file, and you can also delete a file in the file system. You can upload a file to the file system and mention the partition numbers. You can also get the file information. You can also see a file inside a particular partition number, and here you can also see the metrics. All these updates that you make to the file system, you can visualize it over here like this. We can also see that all the updates done over here has also been reflected onto the Firebase. Now, Firebase's real time database has all this information that we have updated. It has created two collections, that is data and metadata. So, metadata has all the metadata of the partition files and the directory structure of the file system, and data consists of the actual partition files contents. So, since Firebase's key does not allow us to enter a special character, I have incorporated dot as a substring instead of the special character period. Now, let's move on to the next subtask. Let's see how EDFS commands are implemented. Um, for each EDFS command, let's look at a success and a failure case. Let's start with the migdir command. For the migdir command, the user has to enter a hyphen migdir and also enter a folder name, a directory name which has not been entered before. So let's say um, uh, users John. Okay, I create a new directory with this name. So once I enter it, I can see that a new directory has been created with the name John, and also I can see a success message. If I open the GUI, there's an option to create a directory. So I can enter, let's say, if I enter a new directory name, let's say Mary. If I click on the create directory option, it creates a directory, and at the same time, I can view it here using this option. You can see that a directory has been created with the name Mary. Now let's look at the failure case of Meter. So I would have to enter a directory name that is already present in the file system. So in this case, I should be expecting a error message saying that is already present. So a directory cannot be created with this name. So if I click on this, I get like a error message which says that this file already exists. So I'm not able to create a directory. Now let's look at the ls command. So in ls, I can just enter the file or the directory whose contents I want to view. So let's say I'm interested in looking at the contents inside this folder. So when I enter it, it shows that there is a file called netflix.xls inside users Anna, and also these are all the partitions in which the file is present. Now let's look at the GUI. So the ls command in on the GUI is the list file. So I can just enter users Anna. Let's consider a success case first, and look at the contents of this directory. So when I click on list file, it shows that there is a Excel file called Netflix inside users Anna. Now let's look at the list file failure case. So let's say we entered a folder name which is not present in this. So in this case, we should get an error message saying that it's not present. So we can see that there's no such file or directory, so we cannot do an ls. Now let's look at the cat command on the EDFS CLI. So cat means to display all the contents of a file. So let's try to run this command. So let's say we have a file um, which is that is like Anna Netflix.xls. Let's consider a success case first. In this case, like we are expecting to see the contents of this file, which is present in the file system. So as you can see that the cat command has completely displayed all the entire contents of the file. So on the GUI, uh, corresponding um, the corresponding function, the command is this show file. So let's try entering the same test case. So now let's see that whether this displays the entire Netflix file or not. Now you can see that here in the navigation pane, it has displayed all the file contents of this, and you can also see that you can scroll through the file and just view all the uh, rows of the file, which is like a very interactive way for the user to go through each and every row instead of looking at this on the command line. This is more visually appealing and more provides like a good user experience. Now let's look at the failure case of the show file, that is the cat command. So let's say that we use the same test case wherein we enter a folder name and a file name that does not exist. So in this case, let's say we take something like James and movies.xlsx and click on show file to cat all the files which are cat this file which is there in the James. So when I click on this, I'm getting this error message saying that there's no such file or directory, which is perfect as that it works as expected. So now let's move on to the next command. So now let's look at the rm command, which is used to remove a file from a file system. So let's try running this command. We know that we have a file called netflix.xls, which is an Excel file in users and Anna. So in users, which is in Anna, which is underneath users. So let's try to remove it. So here you can see that we have two files which are under Anna, and Anna is a subfolder under users. So we try to remove this file, and you can also look at the partitions over here. So let's try to see after removal what the difference is. So now after removal under Anna and under users, uh, we can see that there is only one file which is Netflix underscore titles and not Netflix XLS. So we know that the previous one has been completely removed, and it shows like a success message also after removal. On the GUI, I have like another file also which I can remove from users and Anna. So what I can do is I can type the other file name and try to remove it from this folder from Anna. So I'll click on this delete option. So the delete option opens up this pane, which gives the complete structure, and you can see that Anna, the directory Anna does not have any files underneath it. So now that we have removed those files, let's try putting those files back. So we can just try putting one file right now through the CLI. So let's look at a success case of put. Um, so we can try to put this Netflix underscore titles.csv file into the user's ANA folder, and the number of partitions that I've kept here is 4. So let's see how that works. So you can see that there's a success message seen here. So let's try putting the previously deleted file, and I've kept my number of partitions as 4. When I click on upload file, it takes me to this folder which has my files, and I can click on this one because this has already been uploaded through the CLI. I am thinking of clicking on this one to upload the upload as the next file. So once I do this, I can see the pane here, which is a navigate pane, and I can try looking at the files and see if my files are present or not. So as you can see, as per our input, these two files have been uploaded onto the correct folder. Now let's take a look at the get partition command. To get all the partitions that contain this file, let's enter this command and let's see what it gives us. So here you can see that these are all the partitions that contain this file. Now let's look at the GUI. On the GUI, the corresponding function is the file information. So now if I enter the same file name, I'll get all the partitions that contain this file. So let's do that. So here now we have all the partitions which have this file name. Now let's look at the read partition command. The read partition command takes two arguments, the file name and the partition number. Let's say we have a file called Netflix underscore titles.csv, and we have our number of partitions are four. So let's say we consider only the first one partition, partition number one. When you enter this command, you can see all the file contents in this particular partition. The GUI, the show file of partition is the command, is the option for it. So I can just enter the file name, and also I can enter the partition number, let's say 1. And when I click on this, I can just see all the file and all its records, and you can just scroll down and see all the records, and it's like a very interactive pane. So that's how the success work case works works in this. Now let's try moving on to the failure case. To see the failure case of read partition, I can enter a file name which is not present in the system. I can say, let's say, 3, and I can enter a partition number. It says that there's no such file or directory. Let's take a look at the GUI and look at the map and reduce functions. You can see here there are these three metrics: country, genre, and pop type. So let's take a look at country first. So country, this metric will give all the popular countries where Netflix is gaining more users. So based on this, so what the map function does is it takes the data from the partition and transforms the data. So each map function result is then taken, and the reduce function, it combines these results and then it reduces them and into one final output. So in this way, you can get an idea of where Netflix is growing in popularity. Similarly, you can look at the genre. So in this case, you can see that there are more drama and international movies are getting more popular compared to the other genres. So just like the previous case, it will take output from all the partitions after running map function, and then you'll get the final reduce function. Next, we look at the type. So the type is the type of content, which is either movie or TV shows. So similar to the previous case, it will produce these output for each partition, and then it will combine. Reduce will combine all the outputs from map function and then into aggregate into one particular output. So in this way, you can get insights into the Netflix datasets, and Netflix can use this analysis for their predictive analytics, and it will help and improve their business decision making and also overall improve the user experience. I would like to end my presentation by saying that this project was a good learning experience for me, and I gained several insights into distributed file storage and parallel computation. Thank you.